All right, here we go. Finishing up that quiz, numbers 5 and 6. So both of these, we have the question of is this equation representing exponential growth or is it representing exponential decay? And then we'll give the rate of growth or decay as a percent. Now, we did not cover this together last class, but I'm hoping that you could figure it out if you think about it a little bit. With exponential growth, the equation or the expression looking like this with a 1 plus r, and decay looking like this with a 1 minus r, we're never going to have a negative rate. I'm never going to say, something, a population is growing at negative 7%. That shouldn't happen. So if your rate is always positive, basically 1 plus r, I don't know where I can write this, but 1 plus r is going to be, this is going to be greater than 1. Since we'll add a positive, this will become greater than 1. And here, if you subtract a positive, the percent should never be more than 100%. So the rate should never be more than 1. But this is going to be less than 1. So as far as figuring out is it exponential growth or decay, it's as simple as saying, is your common multiplier, remember that's b in general. We said if we go back to our general equation, y equals a times b to the x. Basically, if b is greater than greater than 1, then it's growth. If b is less than 1, it's decay. That's it. So looking at number 5, and I'm not worried about the 3. The 3 is the initial value. 3 represents A. That doesn't tell me if it's growth or decay. I'm looking at B. So here B is equal to 3, or excuse me, 0.2. I was just saying we don't need the 3. B is 0.2, and that is less than 1. So I go, okay, so this represents decay. Because of this fact right here, that our common multiplier, B, is less than 1, this represents decay. I'll jump to number 6. I know we still need the rate as a percent, but I'm going to jump to number 6. In this case, B is equal to 3, which is greater than 1. So something greater than 1 tells me that this is growth. Now, if you weren't sure about that, if you're like, I forgot it's as simple as just, is your common multiplier greater than 1 or is it less than 1? And that's it. That's all you need to figure out growth or decay. If you forget that, what you could do is you could make a table of values. You'd be like, all right, well, let's take our equation. Maybe let's do some x and y values. And I don't know, what do you want to do? Start with 0 maybe for x, 1, 2. You could do a few of those. You could put your x values into the equation and you could calculate and you could come up with your y values. I'll see if I can do this one real quick here. I know this first one's going to be 3, but you can double check that on the calculator if you want to. Our common multiplier is 0.2. So if you remember when we were identifying exponential functions from a table, we looked for a common multiplication pattern in the y values. In this case, we're going to keep multiplying by 2. So 3 times 0.2 is going to be 0.6. And then 0.6 times 2 is going to be 0.12, I believe. You can verify that on the calculator. I'm pretty sure. Let me do it actually, just to make sure. 3 times 0.2 is 0.6 times 0.2 is 0.12. Okay, so, and then you can say, all right, so as we're increasing x, what happens to the y values? They're getting smaller. So that's another way. It's longer, but it's one of those things. If you forget that shortcut, a common multiplier greater than 1 means growth. A common multiplier less than 1 means decay. If you forget that shortcut, you could crunch the numbers. It's like, my y values are getting smaller. That must be decay. That's where we're going to do that. Or you could do the same thing here. Your y values are going to get bigger. All right, so the rate then. Well, that's all I need is this part for the rate. Again, all I need to look at is B. For decay, I just need to look at 1 minus R for decay. So if we do 1 minus R, is going to be that 0.2. And basically, I just need to solve this equation for R. And I'll have the rate. It'll be in decimal form. We'll get it as a percent overall. But if I solve this for R, then I'll have my rate in decimal form. So let's see here. Be careful with this one. I'm going to start with the growth, actually, because decay is a little tricky. But for this, it would be growth is going to be 1 plus R, and that's going to be the 3. So that one's a little bit easier to solve for R. Take away the 1, you get a positive R. I'm going to put the positive for emphasis. Positive R equals 2. Positive R there. I mean, you could just write R equals 2. But that's the decimal form. That is not saying we're growing at 2%. This is the decimal form. So if you forgot how to change a decimal form to a percent, all you got to do is multiply by 100. So our percent is simply going to be that 2 times 100. So our rate, number 6, this represents an exponential function, an exponential growth function, where you are growing by 200% every time period, whatever X is in. I don't know if it's in years, decades, months, days, but whatever this is, it represents growing by 200% per time period. So remember how I emphasize, I'm like, it's a positive R. That's what we get here. Because this one here, a lot of students will make a mistake. They'll subtract the 1 on both sides. 0.2 minus 1 gives you a negative 0.8. And that's where some students forget the negative. But the trick is that over here, I would count that as a negative R. So this is negative R equals negative 0.8. And remember some of the tricks we can do. We can fill in a 1 here. We can say that's negative 1R equals negative 0.8. And then we can just divide by negative 1. And so we get R equals, that's going to be a positive 0.8, but that's the decimal. Let me grab a chair here. I'm getting low down on the board. This is the rate in decimal form, because that's what we use in our equations. So this is the decimal. So for the percent, just got to multiply that by 100. So 0.8 times 100, that's going to give us 80%. Okay, so this equation represents whatever it is, money, population, that is decaying, decreasing, getting smaller by 80% per time period. So there we go. That's it for that quiz. You should get a new copy, version 2, and see what you can do with that. Thanks for watching.